Lesson 11.6 is going to be adding and subtracting rational expressions. Now, this word rational that we see here, we've seen it in the last few lessons that we've done, the last 2 days before this one, okay? We had, first of all, simplifying rational expressions. Then yesterday we did multiplying and dividing rational expressions. And today we're adding and subtracting rational expressions. Now, if you remember, all the word rational means is that it can be written as a fraction. So we simplified fractions, multiplied and divided fractions, and today we're adding and subtracting fractions. Now, if you remember fractions, all right, this is going back probably to 7th grade math or even before that. If we had 1/2 plus 1/4, could I add those fractions together? No, I cannot. They do not have a common denominator. So in order to add them together, I've got to get a common denominator. What's a good common denominator for 2 and 4? 4, okay? I never want to go smaller. I always want to multiply. You never want to divide or add or subtract. You always want to multiply. So I realize that obviously I don't need to change 4 because it's already 4. But I need to multiply this by 2. Whatever you do to the denominator, you have to do to the numerator. So now I would have 2 over 4 plus 1/4. Then, now that I have my common denominator, you never add those denominators. It always stays the same. So this is going to be a 4, and then I just add my numerators, and I get 3/4, okay? So that's exactly what we're going to be doing today. The only thing that's going to be different is we're going to have some variables in our fractions. And those variables are also going to have to be the same when they're in the denominator. Okay? First of all, though, before we do any of that, we're just going to have a little refresher, and we're going to add and subtract with like denominators. So they've already given you a common denominator. All you need to do is add them, okay, or subtract, whatever it tells you to do. So this first problem here, I have 3y over y plus 5 plus 4 over y plus 5. Well, I realize they've already given me a common denominator, so I'm going to have y plus 5 as my denominator. Remember, you do not add those together and get 2y plus 10. Whatever your common denominator is, it stays as that denominator. Okay? Then I need to add my numerators. Well, first of all, I look at that. 3y plus 4. Can I add those terms together? No, I cannot. The reason why I can't is because they're not like terms. So which one, when I write my final answer, should come first? The 3y or the 4? The 3y, because you always want to write variables first. And when you have more than one variable, you write the variable with the largest exponent first. So I write my 3y, and then I just put plus 4, because I just have to write it out beside it because I can't add it together. I look, okay? Now this is the part where yesterday and the day before's lesson comes into play, all right? Whenever I have a variable and it has a plus or minus sign beside it, what do I need to write? Parentheses, okay? I want to put parentheses because these are a pair. There's nothing I can do to simplify this fraction because whatever's in parentheses is not identical. Now listen carefully to this part because this is what confuses people, is they try to do parentheses like here, or they'll try to put them here or something like that. Okay, you do not have to put parentheses until you have only one fraction. Right here, I've got my final answer, and it's one fraction, so I put parentheses to see, can I simplify that? Because let's say I was adding fractions, and I got 2 over 2. Can I leave my answer as 2 over 2? No, it needs to become 1. So I can simplify that. So that's exactly what I want to do with my fraction. Once I get it down to one fraction, then I see, can I simplify that even farther? And that's when you put the parentheses on. Okay? So let's do the next one. Now look at this next problem. It's different because it is subtraction. All right? I've got a subtraction problem. Now, what you do whenever you have a subtraction problem, everyone listen. Whenever you have subtraction, what you want to do is everything behind the minus sign, you change the sign to whatever the opposite is. So if it's positive, make it a negative. If it's negative, make it a positive. So this x right here needs to become negative x. This 4 needs to become negative 4. And what that does is I now change my subtraction to addition. Okay? So everything behind the minus sign you change. Now, I don't do anything to what is before the minus sign. That stays the same. But everything after, I change the sign to its opposite. And I make it an addition problem. So I look and I notice that I already have a common denominator, which is x plus 2. All right? And then what should I write first? Should I write my x first or should I add my 4's first? X first. Obviously, x does not have any like terms, so I just write negative x. Now, 4 plus negative 4 is what? 0. So, do I need to write negative x plus 0? No. Okay. This is my final answer. I could put parentheses around x plus 2, so I realize I cannot cancel out those x's because x plus 2 is a pair. So, this is my final answer. Okay? Now, let's move on to simplifying after I do an addition or subtraction. This one just happens to be subtraction, okay? But you can simplify after you have addition. All right? So first of all, before I do anything, I check my sign. And I see that, again, this is a subtraction sign. So what do I need to do to everything after the minus? Change the sign. So this 3 is positive, so I make it negative. This 3 is negative, so I make it positive, and I make this an addition problem. Now, okay, I realize I have a common denominator, 2x squared minus 7x plus 5. So I'm going to write my common denominator, 2x squared minus 7x plus 5. And now I've got to add my numerators together, okay? Again, I want to start with the x's because those need to be written first. So negative x plus 3x gives me what? 2x. Okay? Then 1 plus negative 3 gives me negative 2. Now, I am not done because this is just like that fraction that I just said. If you had 2 over 2, can you leave that as your answer? No, you've got to simplify it. So right here I look and I say, okay, this needs parentheses. Is there a greatest common factor I can take out of 2x minus 2? 2. Very good. So let's do that. So I write the 2 on the outside, my greatest common factor. 2 divided by 2 is 1, and I'm left with x, so I don't really need to write that 1 there. You can if you want. Negative 2 divided by 2 is negative 1. Now, anytime I have a trinomial in the denominator, what do they want me to do to it? Factor it. Or if it's in the numerator, it doesn't matter. As long as they give you a trinomial, 9 times out of 10, they want you to factor it. All right, so we need to factor this. First of all, I need to double check and pay attention that I've got a number in front of x squared. So that means I need to multiply a times c, which is 10. List the factors of 10. 1 times 10 and 2 times 5. Now I need to ask myself, which ones will add together to give me 5? I'm sorry, 7. 2 and 5. Now let's double check. I need to make sure I got my signs right. So since this is an addition right here, I know my signs have either got to be plus plus or minus minus. So I look to B. Whatever B is the signs that I'm going to have. So it's going to be minus, minus. Okay? Then I write my next step, which is I take my original problem, 2x squared. Instead of writing negative 7x, remember, I write negative 2x minus 5x. I replace it with the two terms that add together to give me negative 7. And then I write that last term, plus 5. Then I group them together and do factor by grouping. Okay? 2x minus 2x, I'm sorry, 2x squared minus 2x, I can take out a 2 and an x, and I'm left with x minus 1. What can I take out of this second set of parentheses? What kind of 5? It has to be a negative because look right here. That very first term is a negative. So I've got to take out a negative 5. So I take out the negative 5 and I'm left with x minus 1. All right, so my factorization for my problem is going to be 2x minus 5 and x minus 1. Now, is there something here I can simplify?
X minus 1.
The x minus 1s are identical, so I can cancel them out. And I'm left with a final answer of 2 over 2x minus 5. Okay? So that one has a little more work because I've actually got to, once I get down to writing my answer, I've got to simplify it farther. All right, now the last example that we're going to do is we're actually going to add and subtract now that I do not have common denominators. So they're going to expect me to get a common denominator first, and then I can add these problems together. Well, if you look at these problems, they're different than when I just said 1/2 times or plus 1/4, okay? Because they've got variables here. And with a common denominator, you have to have the exact same number with the exact same variable. So let's worry about our numbers first. I've got a 3 and a 6. What is a good common denominator for 3 and 6? 6, very good. I don't want to say, oh, it can be 12, because that's not the smallest number. Then I'm actually doing more work than I need to. Okay, so I want to say it's going to be 6. So this 6 is fine, but I need to multiply this by 2. Whatever you do to the bottom, you've got to do to the top. So I multiply the top by 2. Now, I need to look at the variables. So let's look at the variables. I've got x squared and x. So what would be a good common denominator for the variables? X squared. Very good. I need 2 x's. All right, well, first of all, I look. This one already has x squared. So I don't need to add any x's at all to this problem. But this next problem over here, 6x, only has 1x. So I multiply by x. Whatever you do to the bottom, you've got to do to the top. So my new denominator is going to be 6x squared. Now I just need to write my terms. Okay, 7 times x is 7x, and the reason why I'm doing that first is my variable has to come first. Then plus 5 times 2, which is 10. Now look at this problem here. I need parentheses here once I get to the simplifying step. And is there anything I can simplify now that I've got this? No, because there's no greatest common factor of 7 and 10. I can't do the difference of 2 squares, so this is my final answer. All right, let's do this last problem. Now, this last problem is probably the trickiest, all right? But if you can understand this, then you will be able to do any type of denominator or common denominator problems, okay? All right, first of all, let's look at this. 2x squared over x plus 1 minus x minus 1 over x. Now, people look at these denominators. Well, first of all, before I do denominators, I notice I have a subtraction sign here. So what do I need to do? Change the signs. I need to change this to a plus sign and then change every sign after. So negative x and now positive 1. Okay? Now, I look at my denominators and I have x plus 1 and x. Now, a lot of people go, oh, simple, plus 1. They're the exact same. No. Can I ever add to get a common denominator? Never. You can never add, you can never subtract, and you can never divide. It always has to be multiplication. So I realize, okay, there's nothing I can multiply x plus 1 by to get x. There's nothing I can multiply x by to get x plus 1. Even if I tried to multiply it by 1, what's 1 times x? 1x. So that's definitely not the same. So what I realize when I have a problem like this is there's nothing I can do to make one of them identical to the other. So this is all you've got to do. Is everybody listening? Just multiply them by each other. So x plus 1 needs to be multiplied by x. X needs to be multiplied by x plus 1. When there's no good common denominator, you just multiply them by one another. Just like if I had x over 4 plus x over 5, what would be a good common denominator of 4 and 5? 20. So look, what I do is I multiply this by 5 and this by 4. Do you see how I just did that? That's the exact same thing that you're doing there. Okay? So, now I've got my new common denominator of x times x plus 1. And I need to multiply whatever I do to the bottom, I need to do to the top. So I multiply this by x plus 1. All right, let's do the first fraction first. 2x squared times x is 2x to the third power. Now, look at this last problem right here. Whenever you have two binomials, I have negative x plus 1 and x plus 1, and they're being multiplied by one another, what do you use? FOIL. Remember FOIL, okay? So I've got to use FOIL. I can't just say x times x is x squared, 1 times 1 is 1. No, that won't work. Okay, or I can't combine like terms and say negative x plus x is, well, it cancels out, 1 plus 1 is 2. No, that's not how it works, okay? You've got to do FOIL because I'm multiplying. So negative x times x is negative x squared. Negative x times 1 is negative 1x. 1 times x is 1x. And 1 times 1 is 1. Now I need to combine like terms. All right, I've got 2x cubed because there's no other term that's going to combine with 2x cubed. Negative x squared because there's no other term that's going to combine with x squared. And now I need to add negative 1 plus 1. What's that going to be? 0. It cancels out. Okay? And lastly, I've got plus 1 over x times x plus 1. And you look at that and go, oh, it's a trinomial. They want me to factor it. But look at your exponents. This is a 3 and this is a 2. Normally, you know, we're used to x squared and x. Whenever this term, whatever this term is, okay, the next exponent has to be exactly half of it in order to be able to factor. So what's half of 3? 1.5. Is that exponent 1.5? No. So I cannot factor this, okay? Now, if this was a 4, all right, and this was a 2, then yes, I could factor it because it's exactly half. But it is not. It's a 3. So this is my final answer. There's nothing I can do to simplify this problem any farther, okay? So this is how you add and subtract with like and unlike denominators. Now remember, if it has a common denominator, you never add the denominators. It stays the same. If it's a subtraction sign, you make everything behind the subtraction sign the opposite sign and make it an addition problem. And lastly, once you get down to your final answer, see if you can simplify it any farther.